Good afternoon. Today's lesson is on composite functions. Composite functions is the composition of two functions. In other words, when we take one function and insert it into another function. The notation for a composite function looks like this, which is not read fog of x. This is read f of g of x. And this notation can be written using function notation that we are all very comfortable with. Our outside function stays on the outside, the inside function stays on the inside. So this is f of g of x. When finding the domain of a composite function, it is a set of all values that are in two sets. The first set is the domain of the composite function f of g. In a few minutes, we're going to look at some examples of constructing composite functions. And when we're done, we're looking at just a traditional function where we're identifying if there are any restrictions to the domain. But because it is a composite function, we also have to take into account the inside function. So this is where number 2 is. Number 2 is we also have to look at the values that are in the domain of your inside function. Now I didn't label this g of x because we might change the order depending on the question. So that's why I refer to it as the inside function. It's whichever one is on the inside or listed second in this notation. But again, make sure you're looking at the intersection of both of these. So if it is in the domain of the composite function, it's in the domain of the very end result, but it's also got to be in the domain of our inside function. The second one is the one that we always get tripped up on and forget to check. But we'll see an example of how that works in just a moment. Before finding the domain of a composite function, let's practice evaluating. Given f of x equals the absolute value of x minus 2, and g of x equals 3 divided by x squared plus 2, find f of g of 4. First, we're going to take this and write it using function notation. This is the same as f of g of 4. This tells me plug g of 4 into f. Well, I need to figure out what g of 4 is before I can do that. So looking at my function of g of x, I'm going to plug in 4 for x squared. So this is 3 over 4 squared plus 2. 4 squared is 16. 16 plus 2 is 18. 3 over 18 is 1 over 6. And now we're substituting 1 over 6 into our function of f, which is the absolute value of 1 over 6 minus 2. 1 over 6 minus 2 is going to be 11, negative 11 over 6. And in absolute value, this becomes positive 11 over 6. So we're starting from the inside and working our way out. Let's try another one. G of f of 2. Now my outer and my inner functions have switched. So it is g of f of 2. We're always going to evaluate the inside first. What is f of 2? Plugging in 2 into f of x, 2 minus 2 is 0, and the absolute value of 0 is 0. So this f of 2 was replaced with that value of 0. And now we're just finding g of 0. So plugging that in, 3 over 0 plus 2 equals 3/2. G of 0. These don't cancel each other out just because of the same function. Again, construct your function notation and first find what's on the inside. The very inside is g of 0. Well, if you look in that previous example, we already found g of 0. G of 0 was 3 over 2. So now we're plugging 3 over 2 into our function of g, which is 3 divided by 3 over 2 squared plus 2, or 3 divided by 3 over 2 squared. We're squaring the numerator and the denominator, so we get 9 over 4 plus 2. And I'm going to come over here because I'm running out of space, but I want to show you how we're working with this complex fraction. 3 over 9 over 4 plus 2 is going to be 17 over 4. Multiplying the 2 by 4 over 4, so we've got 9 plus 8 over 4. And when we've got a fraction divided by another fraction, we multiply by the reciprocal of the denominator. So we have 3 times 4 over 17, which is 12 over 17. So that's a nice example because we get a chance to practice those complex fractions, which we haven't seen in a while. Now let's build a composite function and find the domain. So we want to find f of g of x. This will be the most common composite function you'll be asked to find, but make sure you're paying attention to that outside and inside function so you set it up correctly. So we want to find f of g of x. Just like we did previously, we're going to replace the inside with what it equals. In this case, we know that g of x is equal to negative 2 over x. And this notation, our function notation, tells me to take negative 2 over x and plug it into x in f. So we have 1 over negative 2 over x plus 3. Again, we are dealing with a complex fraction and we can't leave it like this. We have to simplify this. So let's work with just the denominator. I'm going to take this and work over here. So negative 2 over x plus 3. First, we want to find a common denominator so I can write those two fractions as 1. My common denominator is x, so I'm going to multiply the 3 by x over x. And this gives me negative 2 plus 3x over x. And I'm going to take this and place it right back where we were. So now my fraction looks like 1 over negative 2 plus 3x over x. And a fraction divided by another fraction. Remember that phrase, keep, change, flip. We keep our numerator. We change from division to multiplication, and then we flip the denominator. X over negative 2 plus 3x. So our composite function, f of g of x, is equal to x divided by negative 2 plus 3x. We look at this and we recognize that it is a rational function. So we have to make sure we eliminate any values that make my denominator equal to 0. So again, over here in my margin, I'm looking to find where is the denominator of my composite function 0. Negative 2 plus 3x equals 0. Adding 2 to both sides, 3x equals 2, x equals 2/3. This we want to exclude from our domain because it's going to make my composite function undefined. That was part 1 in that previous slide where we were talking about how to find the domain, but we also have to look at the domain of my inside function. Looking back, our inside function, g of x, was negative 2 over x. What can we not include in that domain? We cannot include 0. So we add this extra restriction from the restrictions of our inside function. And I'm going to write myself a little note that 0 came from g of x. Let's look at another one. F of x equals x minus 2, and g of x equals the square root of 1 minus x. Again, finding f of g of x, we start by replacing what g of x is. This is f of the square root of 1 minus x. Again, that g of x, we just substituted in what it equals. Now, this notation says to take this whole thing, this whole radical, and plug it in for x in f. So we have the square root of x, the square root of 1 minus x, 1 minus x minus 2. Can we combine the 1 here and this negative 2? The answer is no, because that 1 is underneath the radical. The negative 2 is not. Make sure you don't bring anything under the radical that's not supposed to be there, and you can't take anything out unless you're factoring out a perfect square. So we have our composite function, f of g of x is equal to the square root of 1 minus x minus 2. Now when I look at this composite function, I recognize the presence of the square root. Remember that with a square root function, our argument cannot be negative. So to find the domain here, we're going to find where 1 minus x is greater than or equal to 0. This is the same as being not negative. The easiest way to solve this inequality, we're going to add x to both sides. 1 is greater than or equal to x. And now I can rewrite this so it's easier to process. X is less than or equal to 1. You can always subtract 1 from both sides, but then you'll have to divide by a negative and make sure you flip that inequality symbol. So I know that the domain of this composite function includes values that are less than or equal to 1, as we see here. But I also need to look at that inside function. My inside function was g of x, which is that same radical we've already found. So we have no new restrictions for this composite function. Our domain is going to be from negative infinity to 1, writing that in interval notation. Given f of g of x, determine what functions f of x and g of x were used to come up with it. So we've got our composite function now. The process of finding f of x and g of x is called decomposition. If you guys go on to take a calculus course, you'll look at decomposition again. So we're trying to figure out what was the inside function, what was the outside function. Because again, this is the same as f of g of x. So I took something and plugged it into something else. So if I choose my inside function first, I can look at this and determine what is actually on the inside. Well, it looks like 1 minus or 1 plus x squared is on the inside. The outer function is what we plugged this into. Well, we plugged it into something cubed. So it's x cubed. Now to test to make sure that we did this correctly, we can create the composite function. Again, f of g of x is f of 1 plus x squared, which is this 1 plus x squared being cubed. Now there are other possibilities of composite or the decomposition of f of x and g of x, but this is probably the most common one that we'll see. In our next lesson on inverse functions, we'll look at how we can use composite functions to prove inverses. And so we'll see you next time. Something to look forward to. Have a good day.